In this video, we will discuss the 3D kinetic study for the rigid body. Before we continue, you must know the difference between the mass and mass moment of inertia. In the definition, the mass is the resistance to the translation motion and is an absolute value in the inertia frame. From the Newton's second law, we know that external force will cause a mass to move in translational motion. If we rearrange the equation, we obtain the acceleration equal to force divided by mass. And over here we say mass is resistance because when you increase the mass, then the motion here, the acceleration will reduce. Over here you have a constant mass pushing on two different objects. One object is heavier, which is 50 kg, another one is 5 kg. You should expect the acceleration for the lower mass here will be higher compared to heavier mass. This is because the mass itself is resistant to the translational motion. So if the mass is low, then the resistance will be lower and you can move faster. If the mass here is high, it means the resistance to the motion will be high, therefore you have lower acceleration. By using the same analogy, let's discuss what is mass moment of inertia. First of all, mass moment of inertia is represented by the symbol I, while the mass is represented by symbol m. So you have learned mass is the resistance to the translational motion. On the other hand, mass moment of inertia is resistant to the rotational motion. Instead of absolute value, mass moment of inertia is a relative value. Means that it will be different when you calculate it about different axes. For example, in this case, we have a thin disk where you have x-axis, y-axis, and z-axis here. So if you measure the mass moment of inertia in the y direction here and compare with the z direction and compare with the x direction, you may obtain different values for different axes. From the Euler Second Law, moment or torque will cause an object to rotate with angular acceleration. And if you rearrange this equation, you obtain the angular acceleration alpha equal to the moment or the torque divided by the I. I is the mass moment of inertia, so if you increase this value, the angular acceleration will be reduced. This means that the I is the resistance to the angular motion. We have two cylinders here. For the first cylinder, the mass moment of inertia, let's say, is 60. For the second mass moment of inertia, let's say, is 6. So this one is much lower. Therefore, the resistance to the angular motion will be low. So when we apply the torque, same torque, on both cylinders, for example, the torque is equal to 30 Nm in these two cases, then the cylinder with lower mass moment of inertia will rotate with higher angular acceleration. If your mass moment of inertia is high, then the resistance to the angular motion will be high as well. So in this case, the angular motion, which is the angular acceleration, will be low due to the high resistance here. So you have learned that the mass moment of inertia is the resistance to the angular motion. Higher the resistance, slower the rotation. Let's apply this concept on this scenario here. So you have few objects which is at the same location on this plate, and this plate is located with some angle away from the ground. And you want to know which object will reach to the ground first. For the first case, you have two objects with the same radius, same length, so in terms of the geometry they are the same, but the material is different. The first object is heavier and the second object is lighter. Please make a guess which one will reach to the ground first. In the second case, you have the same material, but this one is much more larger with higher radius. So in terms of the geometry as well as the mass, this object A is much higher than object B. And which one do you think will win the race and reach the ground first? In the last case, you have a solid cylinder compared with the hollow cylinder. And the hollow cylinder is very light compared to this. So which object do you think will reach to the ground faster? You might think the lighter object here can rotate faster, therefore it will reach to the ground faster than this. Some of you might also think heavier mass here will fall down faster compared to lighter mass. So which one is true? Although the experiment here looks simple, but the result can be very non-intuitive. Because the object here is doing rotational motion plus translational motion. Most of the time we are more intuitive for the translational motion, not the rotational motion. In fact, there is no difference for these two cases where these four objects will reach to the ground simultaneously. So you can see that the mass and radius of the object doesn't affect the motion. However, the shape of the object will decide which one will win the race. So you can check the animation here. So you see there is a racing between four objects with different shapes. So these are the four shapes. From this result you can see the solid sphere here reach to the ground faster compared to the other object. And the cylindrical ring or the hollow cylinder here reach to the ground slowest. So what is the secret of the solid sphere here to win the race? To explain why the solid sphere reach first, followed by the solid cylinder at here, and then the spherical cell or the hollow cell here. Lastly is the cylindrical ring. The mass moment of inertia for these four objects are given here. Different appendix might have different XYZ coordinates. You need to select the mass moment of inertia at the axis where the object is rotated. The mass moment of inertia for the solid sphere is same at all the directions and is given by 2 divided by 5 multiplied with the mass of the object multiplied with the radius squared. For the second case, you have the circular cylinder or what we call the solid cylinder. So since the object is rotated in this direction, therefore we need to obtain the mass moment of inertia in x direction. So these are the information that you should look for. So it's equal to 1 divided by 2 multiplied with the mass and multiplied with the A, and A is the radius for the cylinder. So A squared here. Let's change the radius A to R for the ease of comparison. For the third case, you have a hollow sphere, so it's empty inside the sphere here. The mass moment of inertia are the same at all the directions and is given by 2 divided by 3 multiplied with the mass and the radius squared. Lastly, you have the circular cylindrical cell or what we call the hollow cylinder, where it's empty inside the cylinder. Since the hollow cylinder here is rotated in the z-axis, therefore from this appendix you should refer to the mass moment of inertia in the z-axis and is equal to mr squared. When you compare the mass moment of inertia for these four cases, you will see that for the case 4 here, the mass moment of inertia is the highest. And you know that if the mass moment of inertia is high, then the resistance for the angular motion will be high as well. This is the reason why the hollow cylinder here takes the longest time to reach to the ground. The mass moment of inertia for the solid sphere is the lowest. Therefore, the resistance for the angular motion is low as well. So it takes the shortest time to reach to the ground. So you can see it reaches to the ground first. When you compare the mass moment of inertia for these four cases, you will see that this is the lowest mass moment of inertia, followed by this, and lastly, this is the highest mass moment of inertia. Therefore, you can see the result here. The solid sphere reaches to the ground fastest, followed by the circular cylinder, hollow sphere, and the hollow cylinder. To understand the mechanism of a rolling object fall to the ground here, We need to perform a kinetic analysis on the object. First of all, we need to draw the free body diagram for the object. The weight, which is equal to mg, so this is the gravity force acting on the object. Let's assign the coordinate x, y here. Let's look at this triangle. And you should know the angle here is 90 minus angle. So this angle is the same with angle here, which is equal to 90 minus the theta as well. So the angle here will be equal to theta when you consider the angle here equal to 90 degree. 90 degree minus this over here, you obtain the angle here equal to theta. Mg cos theta, you obtain the force component in the negative y direction here. Mg sin theta, you obtain the force component in the x direction. Then you have the normal force acting on the object in the y-axis. Lastly, you have the friction force acting in the negative x direction. Since the object is rotating, therefore we can obtain the torque, which is equal to the radius multiplied with the friction force here. Due to this external force, the object will move in the x direction with mass multiplied with the acceleration. Due to the torque, the object will rotate with the mass moment of inertia multiplied with the angular acceleration. So this is the kinetic diagram for the pure rolling motion. Since the object will move in this direction, therefore this is where the direction for the velocity of the object. For the pure rolling motion, the velocity of the object here will be always equal to the velocity of the circumference due to the rotation for the omega here. So if you take the radius multiplied with the omega, you obtain the velocity of the circumference here. Therefore, the acceleration in the x direction here is equal to the radius multiplied with the angular acceleration. It can be written in omega dot or alpha. Let's look at the rotation motion first. So in this case, the rotation happens in the z direction. Therefore, the summation of the moment in z direction, which is the torque here, is equal to mass moment of inertia multiplied with the alpha. So let's substitute the torque inside. So this is equal to the I alpha, and the alpha here can be obtained from here. And rearrange this, you obtain the alpha equal to ax divided by r, which is this term. Move the radius here to the right hand side, you obtain r squared. Therefore, you should obtain this equation. Let's continue to form the equation of motion for the summation of force in the x direction. So you know summation force in x direction equal to mass multiplied with acceleration in x direction. So you have mg sin theta minus with the force here. So this is the result. You can substitute the friction force here into this equation to obtain a new equation. Rearrange this equation for the ax here, then you should be able to obtain this formula. So let's say the object here is solid or the hollow cylinder. You need to find the I, which is the mass moment of inertia for these two objects. Previously, you have learned that the mass moment of inertia for the solid cylinder and hollow cylinder in this direction that we are interested is equal to these two formulas. Hollow cylinder has a higher mass moment of inertia, which is equal to mr squared. Therefore, we should know that the hollow cylinder has a higher resistance to the angular motion compared to the solid cylinder here. Because the solid cylinder has a low mass moment of inertia, which is equal to 1 over 2 mr squared. So when you compare to this value, it's only half of the hollow cylinder. There is a missing G in this formula. Please help me to correct this. Next, we need to compute this term. So mr squared plus half of the mr squared give you 3 over 2 mr squared. So mr squared here can be cancelled. Therefore, divide it, you obtain 2 over 3 g sin theta. Similarly, mr squared plus mr squared give you 2 mr squared. So mr squared here can be cancelled. You obtain 102 g sine theta. Since the acceleration for the hollow cylinder here is much lower compared to the solid cylinder here, therefore it takes longer time for the hollow cylinder here to reach to the ground, and the solid cylinder will reach to the ground faster because the acceleration is higher. So in this example, you see the mass moment of inertia plays an important role when we have a rotational motion. Most importantly, you must know that higher mass moment of inertia, the resistance to the angular motion will be higher. Therefore, it will take longer time to reach to the ground because the acceleration will be lower. In this example, the acceleration here will change when you have different shape of the object. The acceleration is only depend on the gravity coefficient and the angle of the slope. The mass and radius here can be cancelled out through the calculation, and therefore we are saying that the acceleration does not depend on the mass, radius as well as the length of the object. This is the reason why when you compare two different objects with different mass, different material, but the shape are the same, both of them will reach to the ground simultaneously. And if you compare the object with different radius and different mass, both of them will reach to the ground simultaneously as well. Because you know the acceleration here doesn't depend on the mass and doesn't depend on the radius. The acceleration depends on the mass moment of inertia, where we can see for the hollow cylinder here, the mass moment inertia is higher. Therefore, the acceleration is lower compared to the solid cylinder here. So the object with higher acceleration will reach to the ground faster. This is the reason why the solid cylinder here will reach to the ground faster than the hollow cylinder here. This is the experimental verification performed by the Professor Walter Levin, where you can see when two solid cylinders with different radius, mass, and material here reaching each other, rolling down to the ground. Let's see which object will win. So you can see both of them reach to the ground simultaneously. So this video also demonstrates the same purpose, where both of them reach to the ground simultaneously. How about two solid cylinders here with different mass and material, but the radius are the same? 3, 2, 1. So both of them reach to the ground at the same time. Lastly, let's consider the motion for the solid cylinder and hollow cylinder, where you can see the solid cylinder reach first and the hollow cylinder reach later. The hollow cylinder takes more time to reach to the ground because the mass moment of inertia is high compared to the solid cylinder. Therefore, the resistance to the angular motion is high as well. In this case, angular motion of the hollow cylinder will be slower than the solid cylinder. Mass moment of inertia is important when we study the rotation motion of an object. So please make sure you understand this